Hello, everybody. We're going to do some more indefinite integration today. The big difference is, if you remember, when we do an antiderivative or we do indefinite integration, one of the things I told you in the earlier video is that there are many solutions. Well, today we're going to actually find particular solutions instead of the many solutions. Okay, and if you're given a little information, you can actually find the particular solution. So we're going to solve a problem here. We're going to do an indefinite integration, and I'm going to say we're going to solve a differential equation. So this is just a derivative right here, right? dy dx. We could also write this as y prime. We could have wrote it as f prime of x. It all means the same thing. We're going to do some antiderivative. We're going to we're going to integrate this over here, but we're given a little more information this time, and that is the function actually goes through the point 1, 2. Okay, and we're going to actually be able to solve C because of that. So I'm going to go over here, and I want to actually take the antiderivatives. So the first thing I'm going to do is I'm going to bring dx to the other side. So I'm going to multiply both sides of this equation by dx. And now I've got it looking like this. And of course, we've been integrating. So that means I'm going to actually integrate both sides here. And if I'm going to integrate this side, isn't one of the rules of algebra that I actually have to integrate the other side as well? I can't really just integrate one side. Whatever I do on the right side, I have to do on the left side. Okay, and so let's think here. Well, what I really have in front here is, it's not written, but there's really a y to the 0 right there. So let's see, I add 1 to the exponent, so I get y to the first, and I divide by that exponent, so y to the first divided by 1. Well, y to the first divided by 1 is just simply y. And over on this side, let's do this side, I add 1 to the exponent, so instead of x squared, it becomes x cubed. And then I divide by that exponent. So I divide by 3. And then here, this exponent right here, kind of tricky again, but that really is 3x to the 0. And so I add 1 to the exponent, I get x to the first, and I divide by the 1. And don't forget, I've got that c here. So this y to the first over 1 is y. 3 divided by 3 is really 1, so I've got x cubed. And then 3x, I would never write it that way. I just write it as 3x plus c. And so I have here a solution, but this is not a particular solution. C could be anything. So if I come over real quick and let's take a look. Oh boy. If I come out here and look at Desmos, here is my problem that I had. Remember, we had x cubed minus 3x plus c. And I've got that right here, x cubed minus 3x plus c. And c could be anything. If c is 0, and I've got a little slider set up here. If c is 0, this would be the solution. But if c was 7, this thing shifts up here. If c was minus 2, it shifts over here. C could be all sorts of different things, okay? And depending on what C is, this graph looks a little different. I want to find a particular solution that actually goes through the point 1, 2. So I can figure C out by using that point. That says that if x is 1, y is 2. So I'm going to come over here and I'm going to put in 2 for y. I'm going to put in 1 for x. And I have 2 equals 1 minus 3 plus c. Let's get a little more space here. And I have 2 equals minus 2 plus c. Let's add 2 to both sides. And I get 4 is equal to c. So the actual solution to this problem is y equals x cubed minus 3x, and the c right here is actually 4. So let's go over and see if that works. Let's go back over to Desmos. If I make C 4, do I actually go through the point 1, 2? And I do. Right there is the point 1, 2, and I actually go through that point. So C has to be 4. So the only difference we're doing now is we're still taking an antiderivative, we're still integrating. It's just instead of having an infinite number of answers where C could be anything, we're finding one particular answer that fits the requirement. We're going to try doing a couple more. So let's try this one here. Suppose I told you that f prime of x is equal to 3x squared and f of 2 is equal to 12. All right, so again, I'm going to actually integrate both sides of this. Well, when I take the antiderivative of f prime, I get f of x. And when I take the antiderivative of this right side, let's see, I add 1 to the exponent. So this becomes an x cubed. I need to divide by that exponent, and I need to add c. So we know that f of x equals x cubed plus c. Well, I'd like to find out c. I know that f of 2 is equal to 12. So when x is 2, the output is 12. I can actually solve for c. 12 is equal to, let's see, 2 cubed, 2, 4, 8. C is equal to 4. So the actual particular answer here that we're looking for is f of x is equal to x cubed plus 4, because I actually solved for c. Let's try one more. All right, suppose, not sure why I can't get rid of that problem up there. Suppose that I told you that f double prime of x was equal to 12x. I told you that f prime of 1 was equal to 5, and we knew that f of 2 is equal to 17. And I want to find f of x. So I'm going to start by integrating, again, both sides of this. Well, if I integrate f double prime of x, that would bring me to f prime of x. And if I integrate 12x, well, let's see, I've got x to the first here, so that would become x to the second. I divide by that 2, and I got plus c. So f prime of x would equal 6x squared plus c. I can solve for that c because I know that f prime of 1 is 5. So if I put in 1 here, I will get 5. So let's see, 5 equals 6 plus c. Subtract 6 from both sides. I get minus 1 is equal to c. So the actual solution here is f prime of x is equal to 6x squared, and I know that c is minus 1. Of course, I'm trying to find f of x, not f prime of x, so I'm going to integrate yet again. So if I integrate f prime of x, I would get f of x. And if I integrate 6x squared minus 1, well, let's see, I need to add 1 to the exponent, divide by that exponent. I don't see anything here, but again, keep in mind that's really an x to the 0. So that's going to become minus 1x to the first, and I divide by 1. And again, I've got that constant out here. So let's clean this up a little bit. I've got f of x equals 2x cubed minus x plus c. I'd like to solve for c. Well, don't forget, I actually know that f of 2 is 17. So the output is 17 when the input is 2. Let's solve for c here. I have 17 equals 2 times 2 is 4, times another 2 is 8, times another 2 is 16. I've got 17 equals 14 plus c. C is equal to 3. So my actual solution here, and I'm running out of space, and I don't think they're going to give me any more. My actual solution here is going to be f of x is equal to 2x cubed minus x plus 3. I'm just taking this guy right here, and we just put in what we actually know what c is. Gentlemen, I hope this helps. Please keep in mind, I'm out on Microsoft Teams. I've had guys stop by asking a little question. Most guys are in and out within 5 minutes or so. So please stop by if nothing's making sense or you got any kind of questions, even if it's on an old WebAssign, I would be happy to help you out. And have a great weekend, guys.